Good morning to you all. Today I will be discussing about the secondary treatment of wastewater and specifically about the trickling filters. So let's start. So first of all, I would like to tell you about the primary treatment and the secondary treatment. So primary treatment basically deals with the removal of the large objects like the plastics, rags, leaves. So the process is here. First of all, the raw sewage is coming from here side, and the first is the screening. The large grid of metals are placed whereby the plastics, leaves, rags are separated out from the wastewater. After that, if something any large passes through this screening process, gets into the comminutor where it gets smashed or break down into the small pieces. After that, there is a grit chamber. In this grit chamber, the suspended solid particles get settled at the bottom under the influence of gravity. Then comes the primary clarifier, where the sludge of the primary treatment gets settled under the influence of gravity at the bottom. After that, the treated wastewater, if it attains the permissible limit, is flowed into the river, and if it do not attain the permissible limit, then the secondary treatment occurs and the sludge is thereby disposed for the sludge treatment. Then comes the secondary treatment. Secondary treatment is a biological stage of wastewater treatment that aimed at removing the dissolved and the suspended organic matter by using the microorganisms. It relies on microorganisms, mainly the bacteria, that break down the organic pollutants naturally present in the wastewater. This state significantly reduces the BOD level and help they makes the water safe for the further use and the treatment. So there are two types of methods of secondary treatment. The first is the attached growth system and the second is the suspended growth system. In the attached growth system, the biomass is there attached to the media. Basically, media, we can say there is a platform of like rocks or plastics where the bacteria grow, and after that the wastewater is passed through this media and the clarification happens. For example of this is the trickling filter. And the next is the suspended growth system. In this, the microorganisms are suspended and mixed with the wastewater. Means there is no any the media for the uh, microbes at which they are spreading. Basically, they are mixing with the wastewater, and the entire biomass is in suspension and is treated in aeration. The example of this suspended growth system is the activated sludge process. So here is the whole process of the secondary treatment. Like from here, the raw sewage is coming. This is the aeration tank, or you can say the suspended growth system, where the microbes and the wastewater is mixed thoroughly and the air is being given by this side. And after that, when the when they when the microorganism eat the biodegradable materials. Now let's talk about the trickling filter, which is an important method that is used in the secondary wastewater treatment. A trickling filter is a type of fixed film biological treatment system. It is called the fixed film biological treatment because microorganisms grow on a solid surface rather than being suspended in the water. In this system, the wastewater is sprayed or distributed over the bed of a coarse media like the stones or plastics, and the where water is aerobically treated by the microbial communities that are attached to the media. Now let's look at the components of a trickling filter. First is the filter tank or the reactor vessel. This is the main container where the trickling filter process happens. This tank is usually circular or it may be rectangular. Its size depends on the treatment capacity. The second is the filter media. Basically, this is the surface area for the microbial growth. This is the filter medium here, and the depth is typically 1.2 to 3.6 meters. Types, there are two types: the traditional media that includes the crushed rocks, the gravels, and the slab, and the modern methods that include the plastic modules, synthetic cubes, etc. This diagram shows the internal working of a trickling filter. At the top, we have the sprinklers or the rotating distributor arm. It sprays the incoming wastewater called influent evenly over the filter bed. These influent contain the organic matter that needs to be treated. Below the sprinkle is the filter media. This is the filter media, and it is made up of rocks, plastic modules. It supports the growth of the biofilms, the microorganisms that break down the organic matter present in the wastewater as it trickles down from here. The wastewater flows slowly through this media under the force of gravity. As it moves down, the microorganism digests the pollutant in an aerobic means the oxygen-rich environment that it reaches the filter support, which holds the media in place and allow air to circulate from below. At the bottom, we have the collection system where the treated water is stored and is being discharged from here. So working principle of trickling filter is as follows. The wastewater is sprayed over the top of the filter bed. As I have discussed earlier, as it trickles down through the media, it contacts with the biofilm growing on the media surface. The microorganisms like bacteria, protozoa in the biofilm, they metabolize the organic matter. That metabolized water, or we can say the treated effluent, is collected at the bottom. Then after that, it is carried along with the biomass is carried along with the effluent to a clarifier or the settling tank, and the air is circulating from the bottom to top, providing oxygen for the anaerobic degradation. Now, these are the types of the trickling filter. The first is the low rate trickling filter. In this, the water is coming from this primary settling tank, then is coming to the trickling filter. After this, going to the secondary sedimentation tank and is released or discharged to this. Then comes the high rate trickling filter. In this type of trickling filter, the water or the influent is coming from here, the primary second settlement tank, sedimentation tank. Then it is coming to the trickling filter, and afterwards in the secondary sedimentation tank, and part of the sludge, like 30% of the sludge, is recirculated again before the primary sedimentation tank so as to increase the efficiency or to enhance the removal capacity from the wastewater, and this happens. Now the third is the high rate. In this, the water is coming through this primary sedimentation tank to the trickling filter, and some part of the water is recirculated back, and after in the secondary sedimentation tank, some part of the sludge is also returned back to the PST. Then comes the two-stage trickling filter. In this, the water is coming from this PST to the trickling filter, and basically in this we are using two trickling filters and one secondary sedimentation tank. So after this secondary sedimentation tank, again the water is recirculated to this trickling filter, and the sludge is also returned back before the PST, so as to increase the efficiency, so as to degrade more and more organic pollutants from the this type of trickling filter, as you can develop according to you the designs. Now comes the factors affecting it. The first is the hydraulic load. It refers to the volume of wastewater applied per unit area of the filter per day. It is expressed in meter cube per meter square per day. Its typical range is 20 meter cube per meter square per day depending on the filter design. High hydraulic loading led to the filter flooding that reduced the treatment efficiency. And its formula is Q by A, where Q is the total flow in meter cube per day and A is the surface area in meter square. Now is the organic BOD load. It refers to the amount of organic matter applied to the filter media, expressed in kg BOD meter kg BOD per meter cube per day. High load require recirculation to avoid overloading and ensure the effective biological degradation. This organic BOD load, the formula is Q into BOD by V, where Q is the flow, BOD is the influent BOD in mg per liter, volume is the volume of media, that is meter cube. Now the third is the efficiency. It depends on the design, like you are using whether low rate or high rate, the media type, loading and the recirculation. The low rate trickling filters have removed 75 to 90% BOD. High rate trickling filter with recirculation removes 65 to 85% BOD, and efficiency decreases if overloading or clogging occurs. Formula is E is equals to SI minus SE upon SI, whereas SI is the influent BOD and SE is the effluent BOD into 100. Thank you.